Quadratic equations consist of two parentheses being multiplied by each other, with each parenthesis having either an addition or subtraction sign inside. When you're multiplying quadratics, the order you multiply doesn't really matter, but you do need to make sure that everything gets multiplied by everything. To make our lives a bit simpler, and to make sure our answers are all in the same pattern, we create the system known as FOIL, which stands for first, outer, inner, last. And that's the way you should multiply your quadratics. The first refers to the numbers on the left of both parentheses, or in this case, the 2x and the x. The outer refers to the numbers on the outside of a parentheses, or in this case, again, the 2x, but on the right-hand side, it'll be the -2. The inner numbers are the 1 and x, and the last numbers are the numbers on the right, or the 1 and the -2. The first refers to the numbers on the left of both parentheses, or in this case, the 2x and the x. The outer refers to the numbers on the outside of a parentheses, or in this case, again, the 2x, but on the right-hand side, it'll be the -2. The inner numbers are the 1 and x, and the last numbers are the numbers on the right, or the 1 and the -2. So when I multiply the quadratic using FOIL, I do my first times my first, which is my 2x, times my x. Then I add that to my outer, which is my 2x, times my -2. And then I add my inner, which is my 1, times my x. And then finally I add my last, which is my 1 times my -2. I can then simplify that equation to be 2x squared plus a -4x plus x plus a -2. I can combine my x's in the middle and I get 2x squared minus 3x minus 2. And that's it. There are a few quadratics that become what's known as special situation quadratics, or special quadratics, and this is one of them. Watch what happens when I FOIL. I first do my x times my x, so I get x squared. Then I do my outers, so I get positive 3x. Then my inners, and I get negative 3x. And then my lasts, and I get a -9. When I combine my x's in the middle, my positive 3x and my negative 3x cancel out, and I'm only left with x squared minus 9. Notice how in my final answer I have a perfect square on my left, and then I'm subtracting another perfect square because 9 is the same thing as 3 squared. So I have a perfect square minus another perfect square. That is why this situation is called the difference of two squares. This is a situation you need to memorize. So if you see a problem that follows the pattern x squared minus y squared, you need to know that breaks down to x plus y times x minus y. So in this case here, I could rewrite p squared minus 25. I could rewrite that as p squared minus 5 squared, which means I have the difference of two squares, and that would factor out to be p plus 5 times p minus 5. The difference of two squares is so common on standardized tests that I can virtually guarantee you will see one question that will require you to be able to recognize the difference of two squares. If you have a quadratic expression that you want to factor, meaning that you want to return it back to its two parentheses state before the two parentheses were multiplied, you can do that by looking for two numbers that will multiply to the last number but add to the middle number. And it may be helpful to start with a list. In this case, let's make a list of the numbers that would multiply to -8. So you could have 1 times -8, or -1 times a positive 8, or 2 times -4, and a -2 times a positive 4. Then we look for which set of numbers would add to -2, and we only have one, positive 2 and -4. Therefore, our factored form of this quadratic expression would be x with a positive 2, parentheses, times an x and a negative 4. To solve a quadratic expression, you can take the factored form and set it equal to 0. When you have two numbers that you're multiplying and they equal 0, the only way that's possible is if one of the numbers is 0. So in this case, we know that one of the parentheses, either the x minus 1 or the x plus 3, has to be 0. So you could say x minus 1 is equal to 0, or x plus 3 is equal to 0. And then you just solve for x. We add 1 to both sides on the first equation, and we get x is equal to 1. On the second equation, we subtract 3 from both sides, and we get x is equal to negative 3. So you actually have two equations. This equation will be true if x is equal to 1 or if x is equal to negative 3. We can solve this quadratic by, again, setting its factored form equal to 0. So first, I want to make this expression equal to 0. So I'm going to subtract 7 from both sides. And I get the equation that x squared minus 6x minus 7 is equal to 0. Then I'm going to brainstorm and look for two numbers that will multiply to negative 7 but add to negative 6. I could make a list, and eventually if I did that I would come across that negative 7 and a positive 1 would multiply to negative 7 and add to negative 6. So my factored quadratic will be x minus 7 times x plus 1. And when I multiply those, that will equal 0. Which means either the x minus 7 is 0 or x plus 1 is 0. So I can write the equations, x minus 7 is equal to 0, or x plus 1 is equal to 0. I can add 7 to both sides, and I get x is equal to 7. Or I could subtract 1 from both sides, and I get x is equal to negative 1. Whenever you factor and solve a quadratic, you will get two answers.